Okay, so we have switched to a better marker. Hopefully this shows up a little better on the board. Starting with this video, but here in this video we're going to look at a slightly, maybe easier series to understand, maybe more difficult. 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1, all the way forever, right? So do you understand what the series is?
Yeah.
Do you understand it?
Yeah, I have an idea on what to do about it.
Okay, I want to ask your brother first, and then ask you. Do you have an idea on what you might want to do on this
You can
series?
split it into groups.
You could split it into groups. I want to say that this is X, just like the previous ones. Okay, what groups would you want to take a look at?
Well, the first one is a group.
The first one is a group all by itself. Okay.
Yep. And then the minus one is a group.
The minus one is a group.
Yeah.
Okay.
And then plus one.
Plus one's a group.
Minus one.
Minus
But
one.
you're just doing.
Well, hold on. I want to hear what he has to say. Okay. So what are you going to do with your groups now?
Well, they're all the way. It's groups of minus one and plus one.
Right.
But wait, you start with positive one.
Yep.
So if you go on forever, I think it's either going to equal 0 if it ends in minus 1, or 1 if it ends in a positive 1.
Oh, okay. Very good thinking. This is either going to be 0 or 1, it seems like.
Yeah.
Depending on if the last term is a 1, or if that's going to leave us with 1, right?
Yeah.
Or if the last term is a minus 1, it always seems like it adds up to 0.
But there is no last term.
But there is no last
So
term.
what is it gonna be?
Okay. What was your idea, by the way?
I was gonna split it into this 1 minus 1 plus 1 minus 1 plus 1 minus 1.
Okay, so you were going to group the 1s and the minus 1s together?
Yeah, and if there was an extra 1, like if there was just an extra 1 hanging off, then it would end in 1. If the groups were all even, it would end in 0.
Yeah, it's interesting, isn't it? It's interesting. Why did you want to group the 1s and minus 1s together, by the
So
way?
that they'd cancel out.
They cancel out.
There's no ending to it.
There is no ending to it.
So what's it gonna be?
So what is it going to be? Well, so we can do a similar kind of algebraic intimidation. You ready for some algebraic intimidation?
Yeah.
Are you intimidated?
Well,
Let's look at what minus x would be. Well, it would just be minus 1 plus 1 minus 1 plus 1
my groups would still hold.
minus 1 plus 1
So they do
minus
flip.
1 plus 1. See that?
Yeah.
I just made this term negative. What's minus 1?
It's positive.
Positive 1. So interestingly, minus x equals, nearly the same as this one. Can you see the relationship between minus x, which goes minus 1 plus 1 minus 1 plus 1, and x, which goes 1 minus 1 plus 1?
Well, the negative signs switch.
The negative signs did switch, yep. And there's one other relationship that we can
But
see.
the groups are still the same.
The groups are still the same. There's another way that this series and this series are related to each other.
Well,
They look almost the same.
and they still have all the same numbers.
Yeah, they do.
Except that this one, it's either negative 1 or 0.
Ah, interesting. This one's either minus 1 or 0. What's the difference between this list of numbers and this list of numbers, even though
This one,
pretend I don't have the parentheses?
But the numbers, it's all the same numbers, but the groups are just flipped.
That's right.
It's all the
Yeah.
same numbers, but there's going to be different results.
There's one other slightly sneaky little difference.
well, this one, it can't be 1.
Okay, right. This one looks like it's either minus 1 or 0. This one was either 1 or 0.
What's that thing?
Where's the minus 1? Where does this minus 1 match up with if you were going to match up the series?
Well, it goes there.
It goes there.
And the 1 would go there,
1 could go there.
and the minus 1 goes there.
Well,
So, did we hit all the numbers?
no.
No, there's a 1 at the beginning.
There's a 1 at the end.
So minus x looks like it's x minus 1.
Minus x looks like it's x minus 1. Okay.
Well,
How do I solve this equation?
Well, you can subtract an x, and you get minus 2x equals minus 1. So x equals a half.
That says x equals a half.
What?
What?
That's strange.
1 minus 1 plus 1 minus 1 plus 1 minus 1?
They're all whole numbers.
They're all whole numbers. How do I get a half?
Ugh.
Alright, let me ask you, do you believe this? Do you believe
No.
this adds up to a half?
Not
No.
really.
No, because they're all whole numbers, and whole numbers can't really equal fractions.
Whole numbers can't equal fractions. Sure doesn't seem like it.
No.
Okay, so do you understand why Ellenberg calls this algebraic intimidation?
Yeah,
Yeah.
because people aren't going to really believe this.
We get some strange answers. And this is what I was talking about at the end of the last video. Mathematicians spent a long time trying to work this all out. And there was a French mathematician named Cauchy who studied infinite series and convergence and kind of figured it all out. But a lot of famous mathematicians believe that this should be equal to a half, the series here, including, I think he said Euler believed it. Pretty neat, right?
Cool.
Yeah.
Alright, so do you want to go watch that number file video?
Yeah.
Alright, let's go do that, and then that'll be the end of our little morning of infinite series. Good job, guys.